And hello, everybody. This is Professor Peter Gregory here. Welcome back. I'm going to do a video here for MGT5080, the Numerical Methods course. We're linear programming for Chapter 2. Okay, so I'm going to go through all the steps that you should be doing when you hit one of these problems in here or in practice out in industry. Okay, so I'm going to go in here and I'm going to show the problems. So what I recommend is go take a look at the question. You're going to need to do this in Excel anyway, right? So the first thing we're going to do is I'm going to go to problem 14 here. This is the ones where they were asking about doing solver, okay? So I'm going to try to make this the quick version of it, and then at a certain point I'll backtrack in this video and then take it through slower so people can see what's going on, maybe a little bit slower, okay? So here's the problem, okay? Of course, I'm looking at the instructor version, so you see the solutions there, but let's not worry about that right now. What you want to do when you have these problems is either you need to compose them. If you go through the chapter in the book, I want to make a point here is that the chapter 2 is really good. The beginning of the chapter 2 takes you through the approach, the thinking about this, and then it gets into some details about Excel. So I know it's a little bit challenging because there's some detail in there that you're trying to keep to the main topic about linear programming. Then you have the problem itself. This is like a word problem, as we would call it, or a practical problem for critical thinking and problem solving. And then there is the mechanics of it, the Excel. Okay, so we're going to do all that. All right. So what I would recommend is instead of running back and forth all the time to this question, okay, I would use your favorite screen grab software and grab this. I happen to use something I pay for, but you can use Snipping Tool or you can use Control-Shift-3 or 4 on the Mac. Okay, Snipping Tool is part of the Windows world. So I'm going to take a copy of this. Control-Z, Control-C. Control-C. Okay, so I'm going to take a copy of this over to a sheet that I named problem 214, and I'm going to do the video. Okay, so this is linear programming using solver, Excel built-in solver. Then there's also the analytic solver, which they talk about in the book. You can pay for other tools and get them installed into Excel. All right, so we'll give it a little bit of a name here. We title our page, and I'm going to pick a random cell, and I'm going to put my screen grab here of the problem. Okay, so as I mentioned, I'm going to do the fast version of it here, relatively fast, and then I'm going to go and we'll make part 2 of this, which will follow. It's the same video, but part 2 of this, I'll backtrack and I'll show the different components because you really want to do everything they discuss in the chapter. Okay, so the objective function, okay, our business problem is to maximize C. We don't know anything about this, but if you read chapter 3, you will see that here we have 3 variables, and they may be 3 different kinds of advertising. It's our marketing mix. Where are we going to spend our marketing dollars out there? And this could be the effectiveness of different kinds of marketing, okay? But now the effective, like a Y, has high effectiveness. If whatever we put into Y, we get 12 of. It has a multiplier of 12, and yet that still could be very expensive. Okay, so what we're saying is possibly the eyeballs on your ad. We have one source here that could be print newspaper. The middle one could be online advertising of all kinds, and the third could be magazines. Okay, so we're going to get for any input of Y, for any unit that we put in of Y, we're going to get 12, the results of 12. So if we put in $1 worth of Y, we might get $12 value out of it. It's like an investment. So that's how you should look at what the variables mean here. Okay, so we have a few things. So the first thing I'd like to do is I do mine a little bit different. You can type it just as it is in the chapter here. Okay, so we have an objective function. Okay, that's our business interest. What do we want to do here? We want to maximize that. Okay, and so that equation there, we're going to end up typing in an equation here in a second, but we'll put it up here as a matter of fact. Okay, and then we will have our changing variables will be X, Y, and Z. All right, so we don't know what they are. Changing bars. Okay, those are the ones that we're going to actually move around to see how the output works. Okay, and then we have some parameters. Parameters are the multipliers here, or coefficients the multipliers here in this equation. Okay, so let's type those right in there. It's 4, 12, and 3. 4, 12, and 3. Okay. Okay, so these numbers, this area here is what Solver is going to need. We're going to have to tell Solver use these three cells, and those are the changing variables, and under the covers, Excel Solver is going to play around with them. Okay, but now we have this other set of inequalities here, two sets of inequalities, and we also have the requirement that all of our variables are greater than or equal to 0. Okay, and that gets set, that last part, that gets set in Solver window. When we go to Solver window, we're going to tell it to do that. Okay, but here we need to understand these inequalities. So these are going to be constraint 1. Okay, these inequalities are constraints. Constraint 1. Okay, good enough. I'm lazy. I'm just going to drag that down. Hey, it actually did it for me. It gave me a constraint 2. Gave me a constraint 2. Actually, we actually have our matrix somewhat formed up. Okay, and in this constraint, what we need to do is these areas, these two areas here, are going to be the result of Solver throwing these variables. It's going to do this very quick movement of all these variables up here, these three variables that we have. Okay, and it's going to change them around, and we're going to get a defining function here. Okay, so what is that defining function? Okay, actually to calculate that, we're going to take these other coefficients here of 15, 5, and 12. See what I'm doing there? 15, 5, and 12. And the second constraint says 6x, 2y, 8z. Okay. Okay. And we're going to put formulas in here. Okay, so I'm going to actually paint them. I'll paint them for us so we don't lose it. Let's paint them like that ugly blue there. Okay, that's good. Our changing variables here. Okay, these are things we're not going to type anything in there for. Okay, and we'll change that to, excuse me, let's do ugly green. And then the objective function, I always like to paint in smashing gold yellow there, real loud. Okay, that's what we're after, a really ugly paint scheme here. I'm not claiming any artistry. All right, it's changing variables. Okay, so these three colored areas are what Solver actually plays around with. Okay, so now we look at the constraints. Okay, so we take a look at the two constraints here, and they both are limited to the maximum of 75 or the maximum of 150. Okay, so if you follow, now this does depend on you having followed the example in the book. Okay, so what we're going to do is put, these are the limits over here. Okay, so the first constraining equation has factors of 15, 5, and 12 on x, y, and z, and it can't be larger, yes, it can't be larger than 75, and it can't be larger than 150 here. Okay, now again, if you look at the format of the book, they do a nice job here. And what we need to do is we need to put in just a symbol of less than or equal to here. Okay, how do you get that symbol in here? Okay, pretty simple. Just click on Insert menu item, go to Symbol, and I've been doing these problems, so it actually comes up with a default. It gives me some recently used symbols. I've been using these. Okay, so under the subset mathematical operations, you're going to find these less than or greater than symbols there that we need. Okay, so what do I need? I need a less than or equal to. It's down in my frequent, and it drops it in, and I'm ready to go with that. I've got one, and let's throw another one in there. Okay, so this is just graphical. I mean, it's really nothing's going to happen in the cell. It's just telling us what's going on. And something that I'm going to do right now is I'm going to grab all these cells and I'm going to center them so they look better. Okay, so just set your own standard for how you want your spreadsheets to look, but I create that. All right, so we have this set up. And actually, I believe we can put this right here. I was out one column away than I really needed to be. Okay, all right. So now, as a part of a discussion, I am just going to go through the sum of products here. I'm just going to use the sum of products. Okay, if you're going through the example in the book, they show a lot of great Excel technique to use. Okay, so the first thing is we're going to grab and name that cell. We're going to name that the objective function. Okay, that's the objective function. All right, so we're naming them. If you haven't used this before, there's a little naming box up here. If you click on a cell, its name is just the cell reference, E4, until you change it. Okay, so now we can do a whole range. We can actually name that whole range, which is kind of neat. And we're going to put that in there as changing variables. We're just naming it the changing variables, which it liked. Okay, it actually took it. And then we're going to talk about constraints. Okay, all right, so we named some of these. If we select that range now, we can see it's the changing vars, the changing var. Let's see if we can make that a little bit bigger. There we go. Just make that window a little bigger so we can read it, okay? Okay, so let's start with the objective function, okay? What's the objective function? Well, it takes a set of parameters times the variables here, okay? So we're going to use the sum of products. I'm not going to explain it here, but after I get done with this problem, I will tag onto the back end of this video what the sum of products is all about. You should really know about that. It's very used in Excel and different kinds of, it's basically a weighted average. If you want to think about it, it gets used for weighted averages too. Okay, so the objective function is going to be what? Okay, double click in there, and it's going to be sum product, okay? And it wants arrays, okay? It wants a series of arrays. So what we need is the changing vars. Okay, can I move that out of the way? Yeah, there we go. So it needs this, the first array that I give it, and it actually picks it up in the equation as changing vars. Isn't that kind of cool, right? So then we put a comma in after that, all right? And we put in the parameters. So we take that in there. Okay, we didn't name that yet. Okay, so let's hit enter. Okay, so let's name this section. I didn't name that before. Let's put in here parameters of the objective function. Oh, it gave me a problem here because I used it somewhere else in the workbook. So let me grab this again. We're going to name this parameters vid. Let's see if I get away with that. Great. Okay. So these are the parameters for the vid sheet. This is the sheet that we're doing the video from. Okay. Okay. So let's go back up here. And if I reset, what I'm going to do is I'm going to grab the range again and hit enter. So you have to reset your equation. And once you name if you name a range or a cell in your equation, you have to kind of like touch it again, and then it will understand. So here's, if you look at it, it does the sum of the products of the changing variables, which there are 3 of, against the, and I picked the wrong one. Good thing I did this. All right, let's fix that. It's supposed to be this parameters. That's better. Now it's fixed. Okay, so what it does is take for every changing var, it's going to take the first element for under parameters and multiply the first changing variable, which will be x. Okay, and then it will do the second changing variable multiplied by 12, and then the third by 3. That's what the sum of products does. Now, as I said, I'm going to break this off into a section, and I'm going to go over sum of products, how it works. Because if you don't get it right now, it's not that hard to get, and it's a really valuable tool. Okay, so we have that set. We're not going to touch this green. We're going to tell Solver, you put numbers in here for us. You're going to figure out how to adjust these values of x, y, and z so that it's going to maximize. Okay, so our objective function, I'm going to put in a note. In fact, I'm going to go a little bit further here, and so maximize. All right, that's just going to remind us what's going on there. So I hit enter. Okay, so it's just being used as a title here, just text. Okay, so 0. All right, so far so good. Okay, so now we need to set up this formula here. Now, again, Solver will end up putting values in here, or it's going to watch these. It's going to change the changing variables, and it's going to watch the results. These 2 results are your constraints, and it's going to watch the objective function. Okay, so we're going to use sum of products again. Sum products. Okay. Sum of products. Oh, sum product. I am sorry. It's one. It doesn't have an S on it. Sum product. We want the changing variables as one array, comma, and we want these parameters down here. Okay, so hit enter. Okay, so right now it thinks that there's zeros in here, and that's why you get a 0 objective function and a 0 here. Okay, And if I just copy this down, let's see if it did it right. D9. Yeah, okay. So what happens is one of the reasons why you want to name your ranges is, see, we have this range named here, change vars, okay? And if I drag it down, it doesn't do auto increment on the cell references. So once you use a name for a range, then that's the same as using absolute reference. That's the beauty of it. So I grabbed this formula, and you can see it says changing vars times D8 through F8, and I dragged it down, and it incremented D9, F9. So it knew to hold the references here steady, but reference against the reference against the second level of constraints. Okay, so we have all this done. We're going to tell, basically what we're going to do for solver is we're going to say, try to maximize this thing, change these variables, and these numbers have a limitation here with 75 and 150. That's what solver does. Okay, so this is the basic format for it. I just put the objective function up front because that's what we're really interested in. Give me the big news first. Okay, so let's run solver. We go to data, and we go to solver, and it might have some stuff. No, okay, it's clean. There's nothing in there. Sometimes it carries over from the last time you use it. Okay, and so it says set the objective. All right, so let's make sure that's selected, and we tell it that D5 is what we're trying to maximize. So it was already selected as maximize. All right, so we could try to minimize it, or we could make a target value. We could shoot for a target value of this. Okay, but so now by changing variable cells, well, the changing variables, we could put all those three in there. Okay, see how fast we're moving along here. Okay, so now we have to add the constraints. And so we add, what's the problem? Why are we having a problem? We want that. Maybe I didn't hit enter. I do find solver behaves a little bit strange. Like it doesn't let you progress. It starts yelling at you. Okay, so the objective function, got that straight now. We're trying to maximize. It knows the changing variables. Let's go back here. For some reason, it was throwing an error. I don't know why. Okay, so cell reference. Okay, so we want to make sure this cell is, okay, less than or equal to. It's set up already for that. So we have less than or equal to. And it has to be less than or equal to 75. And let's add the other one, and we go there. Second one, less than or equal to 150. But we're using the cell references, of course. Okay, and we say okay. It comes back, and you do want to check make unconstrained variables non-negative, and that's the part I said we'd come back to. These are non-negative. Okay, so our variables, our changing variables, have to be larger than 0, which is a real-world problem for the most part. And then as far as the method goes, just use the GRG, which is, I'm going to be honest straight up with you, I always forget what the name of that is. Excel, there it is. Which one of these tells me what it is? Generalized reduced gradient. I'll actually put that in there, okay, so I don't want to forget that. I already looked it up once today. All right, so come back over here. You can make your spreadsheets kind of nice. I'll add it in a second. It's not going to let me insert it until I get through running this. Okay, so let's solve it. We're going to let it run. And if it doesn't work, it'll say something's wrong here. Like if you don't get the problem in there correctly, or if it just doesn't have any valid or feasible results, then it will yell at you and say why. Okay, and this is a part of solver that if you're not getting it right, it's a little bit annoying. It doesn't handle your mistake very well. It keeps you in this loop that you have to try to work on it till it's right. Okay, so we're just going to say, okay, now see what we notice here is yellow, green, and blue are filled in, right? That's what we're after. So it takes care of these parts. As long as we set up our problem correctly, then you're going to get the right results there. That's it. You just have to set it up in Excel the right way, understand what it is. And when you're getting these types of problems that we have, it's pretty much just thinking about what parts are what. What are the parameters? What are the changing variables? Okay. And in the constraints, they each have their own set of parameters. Okay. So done. Okay. So hang in there. We're going to do a really fast problem 15. We're going to come back to problem 15. Okay. because problem 15 is very similar to this. Well, let's make sure we got our answers correct. All right. So in this marketing mix problem, okay, it's just the way that the objective function is and your constraints are. It turns out that we had 0 of x, 15 of y, and 0 of z. So that's kind of interesting. See, we're not even going to use any of x and z. And the way that I described it, I think y was going to be our online. It was going to be our online advertising. If you look at the problem, it had a much higher multiplier. We had much more effect for every dollar we put into Y. You get 12 return. If you put a dollar into one of these other ones, you either get a 4x return or a 3z return. And so the constraints are such that that these are the numbers we get. So let's go back over. Did we get those numbers? 0, 15, 0, 180. Okay. So there, our objective function is we got a result of our marketing of 180, like $1,000 or $1 million or whatever it is. Okay. Through this advertising, through these equations, we came up with $180 million of value from that. And sure enough, we got the right things. Remember, it said 0x, 15y, 0z. Okay. And then of the constraints, what if we added we're going to add a constraint on here, and it says there aren't 15 units of advertising available. Okay, we would love to have 15, but they don't have them to sell. So what if it were limited to 10? Okay, so this is going to add our new constraint here. Okay, make that blue, and what we're saying is, what if we add in the constraint that it has to be less than or equal to 12? There's only 12 units available. Okay, or even harder, let's go to 10. Let's make it 10. So that's what the realistic meaning of what the constraints are. Okay, so there's other constraints say what they do, and then I said, well, okay, you have to cap this thing off. It can't go larger than 15. Let's go run solver on it, and we're going to get a different answer. And what it's going to do, it's going to push. We're going to end up with 10 y's, but then we're going to end up with something in x and something in z. It's probably going to be all in x. That's my bet. See, we get a better return. 4 versus 3, we get a better return on x. So it's going to throw everything it can't put into y into x. That's what I think is going to happen. So solver, we have to add this has to be less than or equal to that. Okay, so I just added another constraint. And that's how the problems really build up in the real world. You get the general one in there, and then you start adding in some other factors as it goes along, and then it gets kind of complicated. And somebody walking in on it thinks you're a genius, but really what it is that you started with something simple and kept adding things on, and you are a genius. But anyway, let's see what happens here. Okay, so it did find a solution, and I say okay. And so it did what I thought it was going to do, okay? Notice that our objective function is now less. We're not getting 180, we're getting 127, or parts of it, okay? And so as soon as we said there's not that many Ys available, you only have 10 Ys, like 10 units of online advertising, it had to go check these other two items here, and they're unconstrained. There's no constraint on naked x or naked z, but we put in a constraint on naked y. Y could not be larger than 10. Okay. All right. So that's why we ended up pushing it over here. And again, that's what happens. You get a phone call from some advertisers and say, we don't have the real estate for you on websites anymore. You have to throw your money. You know, we would take your money if we had the room. We had 15 units for you available, but now we don't. We took someone else paid more money, and we used that advertising space for someone paying us more highly. And hopefully by discussing that, it shows you how you would use this. All right. It's too much to comprehend in your head that you use solver for it to figure out how to maximize these things. Now, here's the beauty of it. Okay, so I'm going to take this page in itself, it's its own lesson. I'm going to copy this over. So move or copy. So we're going to copy. I want a copy of that. And basically, I want it at the end. Okay, it's going to be right after this page. So we got a copy of it. I'm going to edit the name of this page. I'm going to make it 15. Okay, so it's problem. Oops, let me get that. Problem 15. for the vid. All right, we've got it. Okay, so what I'm going to do is go get the screen grab for problem 15, and it's almost identical. You'll see. All right, I'm going to copy that out, do a screen grab. Okay, get rid of this because we're not doing 15. We're doing 14. We're doing 15. I'm going to do another screen grab of it because I didn't get the number. I want to show that. Okay, there we go. We're going to remove this constraint. Okay. Yeah, let's just erase that. Let's get rid of that for now. Okay. And let's take a look at our question. It says minimize C, and it's the same equation, okay? And everything else is the same. 15, 5, 12s, 6, 2, 8s are the same, okay? But now we want it to be larger than equal to 75. So I'm going to delete that and go back to insert, symbol, and now we want the other symbol, greater than or equal to. We go in here and we just copy it down one, all right? Those numbers don't change, 75, 150. All of our parameters have to, all of our changing cells have to be larger than 0. The values have to be larger than 0. Okay, and anything else here, okay? So again, the colored cells here are what solver tickle toggles to maximize, okay? So let's go back to solver. I have to go to data menu item, go to solver. Okay, we're going to remove this one. Okay, we don't want that in there. And we want to minimize the objective values, right? And we have to change our equations, all right? So our constraints, we have to change instead of less than or equal to, okay? So let's change that. And all I have to do is come down and say greater than or equal to, and say okay. And we'll grab the other one and edit. And we're going to change that greater than or equal to. Okay. And so I think we're ready to solve. Okay, and no flags came up here. It says, well, we came up with something. Now double check it. Make sure it makes sense in the real world, okay? Excuse me. All right, so those are still active, okay? And let's double check on that. We got the same numbers as before. Changing values. G10 has to be, G10 has to be greater than 8 and 10. I see. Okay, so I made a mistake here. So G8, okay, we'll deal with that. Okay, so this value here has to be bigger than this, and I got rid of the wrong function here. So let me edit this. Okay, so we need to edit this, and what we'll do is we're just going to say, I think we have this 8. Yeah, so we need that is greater than or equal to that. I had erased the wrong formula and I edited the wrong formula. Okay, so we're all done. Let's run that again. Okay, that looks better. Okay. Or does it? It still doesn't look right. 8, G8 has to be greater than or equal to 75. And G9 has to be greater than or equal to I9. That seems like it should work. Changing barrels, minimize. That's weird. Why did it change? Yeah, for some reason it changed it back for some reason. I don't understand what happened. I'm sorry about that, but here we go. Okay, so let's go check the answers. How did we do on this? Okay, the answers are 0x, 0y, but 18.75 z's, and a total of 56.25. There's our 56.25. 18.75. So we got solver to work. I don't know what happened there. It kind of reverted to some old answers, but everything looks good. All right. Okay, so with that, here we have a problem with three variables, a couple equations. We have our changing variables, our objective function, and parameters and constraints. Okay, those are all the words, the vocabulary around here that you need to do that. Okay, now what I'm going to do, you can stop here, but I'm going to continue here with what is the sum of products all about. Okay, so maybe you jumped here, you started watching the video and you jumped here to figure out what the sum of products is all about. Okay, so I'm going to introduce something called another sheet, and I'm going to name it SPRODs, sum of products, or sum of product example. All right. So if you run a course like I am here, you'll have a number of activities. Activity 1, activity 2, activity 3, activity 4. Okay, so you will have connect homeworks, you'll have quizzes, final project, and final exam, something like that, right? And so you can think of some of so what we would do, and I actually do in my grading sheets here, is we assign weights to this. Okay, so this is an example of when you would use sum of products, right? And so we would assign weights to this, and I would say all your homeworks are worth 25%, and then your quizzes, the total is going to be worth 30%, and then your final exam is going to be worth 25%, and then finally, what does that come out to? 50, 80, and so finally your final project is going to be worth 20%, right? That's what you would do, and literally that's what my files look like when I create them to do grading at the beginning of the semester. All right. And then let's say that you got an 80 on homeworks, 90 on quizzes. The final exam, you had a really bad day and you got an 86. And then finally, your final project, you did pretty well and you got an 88. Okay, let's say that those are your grades, right? So these are the parameters. These are the multiplier. These are the values of the X, Y, Z, A. Okay, so we've got A, B, C, D, E. A, B, C, D would be your variables here, X, Y, Z, A. Like 4 variables because we have 4 different items that are getting scored. Okay, so how would I figure out your averages here? Is what I would do is I would take a bunch of terms. I have 4 terms there. Okay, and this is literally, if I do the equations this way, this is the way I do them. I set them up so that the format's correct first, and then I go back in and I said, okay, so the first term is going to be that times that, and the second term is going to be weighted that times your actual score, and the third one is going to be the weight times your actual score, and the fourth one is going to be weight times actual score. Okay, and hit enter. Okay, so on average you got an 86. Okay, so your homework's dragged you down. You got an 80 on those. All right, so that's why it came down to about 86. You had some other nice scores in there, but there you have it. Okay, so it's the weighted score of this. All right, so it's going to be your grade, and this is going to be your activity. Okay, so we'll throw a little formatting on there. Okay, so if you formatted this thing nicely for yourself, you might do this with it. This is very typical of what I would do to format it. So we're being easy on our eyes. It helps us organize what we're looking at. Okay, so these are like the header, the column header names on it, and your row headers and different things. And this is your objective function. Just going to move it there. This is your objective function. You want to make that as high as possible. I'd throw that as yellow. Okay, and then these are your what we call like your coefficients or parameters or weights for a weighted average. All right, so we'll fill that up with an ugly baby blue like that. Okay, so we made it look a little bit better. Okay, so our eyes can pick up on what parts of this are different than others. I would even center that up. Seems like a small thing, but I would actually be doing this. It really helps you visualize or see what's going on here. Okay, so what's the alternate way? We're going to use sum of products as the same thing. We had, okay, so if we show what that equation is, we have the sum. There's a lot of pluses of all these different products. Each term is a product. That's what sum products is. That's all it is. It doesn't have anything specifically to do with linear programming. So some product. All right. And so what we would do is there's our parameter set, and we want to multiply that against this array here, right? And we get the same answer. How about that? Okay, so that's what the sum of products is. It's nothing special to do with linear programming, but it comes up so often. Okay, so that's it. If you have any questions, let me know. I hope this helps, and all the best for the rest of the course. Bye now.